All right, welcome to the second part of the memory unit. Let's begin. All right, so we're going to start by watching this short video. The scene is you are sitting at a street side cafe enjoying your lunch. You're in a busy city, there's people driving around, walking around this busy sidewalk, and you're simply sitting there at your table enjoying your lunch. All right, we'll come back to that later on in this lecture. So I want to start by talking about the neural basis of memory. So the physical structures in our brain that are used during memory processing when we're storing memories away or retrieving those memories from storage. If you remember, we talked about implicit and explicit memories. Implicit memories are those unconscious memories, motor movements, procedural memories, how to tie our shoes, how to ride a bike. Turns out those memories are stored in the cerebellum for the most part. This is not completely across the board, but most of these implicit memories are stored in the cerebellum. Now, if you remember, the cerebellum is part of the brainstem. It's this funky looking chunk of neurons hanging off the back end of our brain here that I'm circling here. And this is really, really important. The cerebellum is involved with all of those implicit memories. So if you play any sports like hockey, how to take a slap shot, how to skate forwards, how to skate backwards, those are all motor movements that are stored in your cerebellum. Things like classical conditioning. So when you associate two stimuli occurring together, that information is a memory, and that is also stored in the cerebellum. So our other main form of memories are explicit memories. These are conscious memories. And if you remember, these are usually memories that have a specific time and place associated with them. So you remember that one time that you met up with a friend and had a really good time going for a hike at this one specific state park. That's an explicit memory. There's a specific time and place associated with that memory, and it's a very conscious retrieval of that memory. So these explicit memories are created in the hippocampus, and the hippocampus is a structure in the limbic system. And if you remember our friends Clive Waring and HM, they famously had their hippocampus or hippocampi destroyed for various reasons. Clive Waring was actually a viral infection. HM was sort of an experimental surgery. So in each of these case studies, they had their hippocampuses destroyed, and after that, they could not form new explicit memories. Their implicit memories were just fine. That's because their cerebellum was still functioning just fine. But their hippocampus was destroyed, and as a result, they were unable to form new conscious memories. So the hippocampus is involved with creating explicit memories, but those memories, once they're created, are stored in some different places. We have a lot of evidence that for the most part they're stored in the frontal lobes, but we also have some evidence that they're stored in a distributed fashion. What that means is that they're stored all across the cortex. There's no one part of the brain in particular that they're stored. But this is kind of a debate that's actively going on right now in the memory literature, but the evidence is kind of pointing more towards this frontal lobe idea that memories are stored in the frontal lobes. But We have evidence of both. We'll just leave it at that. So if you were unfortunate enough to experience a traumatic brain injury to your frontal lobes, you might experience some form of amnesia. Let's talk about amnesia. So amnesia is a general term for memory problems, and that could mean a lot of different things. You could have problems creating memories, like HM and Clive Wearing. That's a very extreme form of amnesia. Or you could have problems retrieving those memories. So your hippocampus is fully intact, but for whatever reason, you're having difficulties pulling memories out of the frontal lobe or different areas of the cortex. Amnesia could be due to a TBI, which stands for a traumatic brain injury. Could be due to different diseases. Clive Wearing famously had a viral infection. It's a form of hepatitis that destroyed his hippocampus. Stroke is another way that amnesia can come about. A stroke occurs when there's a blockage in different arteries leading to the brain, and different parts of the brain actually die because they don't get nutrients from blood. So, if someone experiences amnesia, we can look at the two different types of memory that we've talked about. Implicit memory. If someone is experiencing implicit memory amnesia, so troubles with implicit memory, this is exceedingly rare and it's incredibly dangerous. Remember, we're talking about the cerebellum, which is located in the brainstem. And if there's some sort of trauma that attacks the cerebellum, that is likely going to cause some pretty severe complications. Remember, the brainstem is where different life supporting functions are controlled. So, the making your heart beat, making your lungs breathe, those functions are all controlled in the brainstem. So if you're having something that damages the cerebellum, it's likely that those other really important features are going to be destroyed as well. What's much more common is explicit memory amnesia. And we usually break this up into retrograde and anterograde. Retrograde amnesia is memory problems for memories that occurred before the amnesia occurred. So let's say someone had a traumatic brain injury. So retrograde amnesia would be difficulty retrieving memories from before the accident. Anterograde amnesia is the exact opposite. Anterograde amnesia is memory problems after the traumatic brain injury has occurred. So anterograde amnesia would be what's going on with Clive Wearing and HM. They had their trauma, their hippocampus was destroyed, and then after the hippocampus was destroyed, they had problems making new memories. So retrograde amnesia is probably what you're more familiar with from movies and TV shows. That's where someone gets hit in the head, and then after that, they don't know who they are or where they live or anything about their life. And over the course of the movie, they slowly regain that information. That's retrograde amnesia. Anterograde is the memory problems following an injury. So let's talk about forgetting. Amnesia is obviously a very extreme form of forgetting, but some level of forgetting is absolutely normal, and turns out it's actually healthy. It's a normal, healthy part of a well-functioning brain. So I want to introduce this idea of adaptive memory. And adaptive memory is the idea that memory was made for a specific survival purpose. So memory is there to help us survive in the world. So think about this for a little bit. Forgetting is adaptive. It would not be helpful to remember every little detail all throughout your day. You go to the lunch cafeteria and you're filling up your drink at the fountain, and you reach for the cup where the straws are held, and the cup full of straws is empty. Minor inconvenience, definitely not something that's worth remembering for the next 20, 30, 40, 50 years of your life. That's not important information. You don't need to know that the cafeteria was out of straws that one day. That's not information that you need to keep with you and have some sort of influence over your behavior for the rest of your life. So it's good for us to forget little details like that. And the research is still coming out on this, but we think that is one of the major roles of sleep. There seems to be a lot of cognitive functioning going on while we're sleeping, and this might be one of those important functions. During deep cycles of sleep, these unimportant memories might help get flushed out and forgotten instead of taking up valuable cognitive real estate. All right, so let's talk about normal forgetting. Researchers have gone back and forth about why it is that we forget, and there's a couple different ideas out there. Two of the main ideas are that we forget due to decay or interference. Decay is that memories simply fade over time. So, simply with the passage of time, we're going to forget things. The other main idea is interference. And this is not just that memories fade with time, but rather they're overwritten with new memories. So if you remember or you gain new knowledge, and then as time passes, you learn more knowledge, that new knowledge is going to interfere with old knowledge that you've already learned. And the research literature is kind of tilting towards this idea of interference over the idea of decay. Decay is kind of an older idea, interference is sort of the newer idea. So we can break down interference into two main types, proactive interference and retroactive interference. So take a look at this diagram on the right side of the slide. We've got our friendly looking fella here, and he's learning material A. Material A is first in time. So he's learning material A. He's learned it. Good job. Time passes, and now he's trying to learn material B. But material B is very similar to material A. So his past knowledge of material A is going to interfere with his ability to learn material B. This is what we call proactive interference. Your ability to remember and recall and use material B is being hampered by your previous experience with material A. So retrieving material B is going to be a little bit harder because of past material A. So think of the interference moving forward in time, proactively moving forward in time. Retroactive interference is the exact opposite. You learned material A, then you learned material B. Now you're in a situation where you need to recall material A, the first thing that you learned, but your experience with material B, the thing that you learned later, is hampering that ability. You're having trouble pulling material A out of your brain because of your experience with material B. So this time the interference is moving backwards in time. It's retroactive interference. So those are our two main types of interference, proactive and retroactive. Those are some examples from my own life. Proactive interference, I learned how to operate a computer first on a Macintosh, and then I learned how to operate computers on a Windows operating system. And my ability to use a Windows machine was actually hampered my past experience with a Macintosh computer. So in that example, the interference was moving forward in time, so that was proactive. And we'll skip that second example there. Moving on. Another very common form of forgetting. I'm sure each and every one in this class has had this happen to them at some point. The tip of the tongue phenomenon. The tip of the tongue is when we know something, but we just can't quite spit it out. We know that we know the answer to a question, or we know someone's name, or the name of a town or a place or something like that, but it's just on the tip of our tongues. We can't quite spit it out. This is actually something that's been studied quite extensively in the memory literature. And we have some examples here on the slide. These examples are some of the examples that are typically used in tip of the tongue experiments to induce a tip of the tongue state in a laboratory. So let's see if these examples can induce a tip of the tongue in any of you guys. First one here, an oblong frame with rows of wires or grooves along which beads are slid, used for calculating. Does anyone remember what that is? The answer there is abacus. The second one, shedding leaves each year as opposed to evergreen. The answer here is deciduous. And first name of main character in Charles Dickens' A Christmas Carol. That would be Ebenezer, Ebenezer Scrooge. So what they do in some of these experiments is they give people these little examples here, these descriptions of something, be it a name or a noun, and they try to induce these tip of the tongue states, and then they try different things to try to alleviate those tip of the tongue states. And I just add this little tidbit at the bottom of the slide here. ASL stands for American Sign Language, and people who speak, or not speak, but people who use sign language actually experience something very similar to a tip of the tongue, but they call it a tip of the finger. All right, so what's going on with the tip of the tongue phenomenon? What we have is competing phonological activation in the mental lexicon. Now we're going to break that down so it's a little bit more understandable. So here we have a model of words in our lexicon. In the very middle, we have the word badge, and then connected to the word badge, we have every single phonological neighbor. Phonological neighbor is a word that sounds very similar to another word. So a word that sounds similar to badge would be bash. Another word would be budge, batch, ban, bang, bass, and so on and so forth. You can go around. This is badge's phonological neighborhood, all of the phonological neighbors of the word badge. On the right-hand side of the slide, we have the word log. And once again, we have the phonological neighbors of the word log. We have loss, dog, league, leg, fog, so on and so forth. So you have these models in your lexicon. The lexicon is your internal vocabulary, so every single word you know in a given language. And let's say you're having a tip of the tongue for the word badge. For whatever reason, you just can't think of this word here. So what you start doing is you activate the neighbors. You activate bang, bass, bat, bath, bag, bad. You're trying to think of that word. You know what the word is. You can describe the word. You might even know what the first letter of the word is, but you just can't think of this word in the middle here, badge. So you're hitting all of these neighbors here, and you're activating them. Activation starts at this particular word that you're pulling from memory, and it spreads along these lines to words that sound similar. So when you're trying to recall this word badge, but you're failing, and you're activating all these neighbors, you're sending a lot of activation into this neighborhood. That activation is creating noise, and that noise is making it more difficult to retrieve the one word that you're trying to pull out, which is right in the middle, badge. So the cure for that is to simply not try and retrieve that word from your lexicon. Don't think about the word that you're trying to pull out of your lexicon. As time passes, that activation is going to dissipate. It's going to spread out to other areas of the network, other areas of your lexicon, and it's going to make the target word, badge, stand out a lot easier. So that is that is the solution to a tip of the tongue phenomenon. Stop thinking about it. Let 5 minutes pass and come back to that question. Okay, what is that word that I'm trying to pull out of my lexicon? What is that word that's on the tip of my tongue? And these tip of the tongue states, unfortunately, they increase with age. Not something to look forward to exactly. So that's a little bit about the tip of the tongue. And let's move on to some ways we can improve our memory. This is maybe something you've heard about before. This is the spacing effect. So this is massed studying versus distributed studying. Massed studying would be cramming all night before an exam. Distributed studying would be studying a little bit every single day. So if if we take a look at this graph here, we've got Leslie, Leanne, and Nora. Leslie studies half an hour every single day. Every single day, right up until the test. Turns out Leslie gets an A. Leanne studies 1 hour for only 4 days before the exam. Leslie gets a B, or Leanne gets a B. Nora, however, waits until the very last minute, studies 4 hours the night before the exam, and Nora gets a C. So this is a very simplified scenario here, but this is kind of a real world example. If you spread out your studying, even though all three people in our example here studied the same total amount of time, they all studied 4 hours total, they used it differently. Leslie broke it up into really small chunks of half hours. Leanne broke it up into 4 chunks of 1 hour, and Nora did it all at once. Research shows that people like Leslie who break it up into small chunks do the best when it comes to a recall exam, like a test or a normal exam for a class. Why does this happen? This happens because of difference in retrieval intervals. So Leslie is studying the material half an hour for every day. So every day she's testing herself. She's getting practice retrieving that information from her memory. And that's what an exam is. It's testing how well you retrieve that information from your memory. The more practice you have at doing that, the better you will do on an exam. Nora, the other extreme example here, she's simply studying for 4 hours straight. She has no practice retrieving that from her memory, or very little practice throughout her 4 hours the night before the exam. So she doesn't have as much practice pulling that information from memory, and her grade reflects that. All right, other ways we can improve memory in normal everyday life. Context-dependent learning. Context-dependent learning means place-dependent learning, the context or the place that you learned information. So the environment that you learn information in is going to be an important retrieval cue when you're tested on that information. There's a really famous memory experiment where scuba divers learned words on a vocabulary exam or a vocabulary test. They were later tested on that, and it turns out if their study environment was similar to their test environment, they did much, much better. So what that means is if they studied the words on land and then were tested on land, they did really well. If they studied the words underwater and then were tested on the words underwater, they also did pretty well. They did poorly if the study environment and the test environment differed. So if they studied on land and then tested underwater, they did poorly. If they studied underwater and then tested on land, they also did poorly. So this is kind of an extreme example, but the more similar your environment is in the study phase as it is to the test phase, in general, the better you are going to do on that recall test. Think about this in your own life. It would actually be best if you study and take the test in the same environment. So if you're used to studying in your dorm or your apartment, take the test in your dorm or your apartment. If you're used to studying in the library or coffee shop, take the test in your library or coffee shop. That's one cheap, easy way to kind of improve your grade. State-dependent learning. This is the same idea as context-dependent learning, but state here refers to your mental state, your internal mental state. So if you're really tired when you're studying, it might be a little bit helpful to take the test in a similar mindset when you're also a little tired. If you're totally jacked up on caffeine when you're studying, you're on your 5th cup of coffee while you're studying, maybe be jacked up on caffeine when you take the test. Substances. So caffeine's not the only substances. There is evidence that, and I certainly don't recommend this, but there is evidence to show that alcohol, marijuana have similar influences on state-dependent learning. So that's to say, if you're drunk when you study, it might be a good idea to be a little bit drunk when you take your test. Once again, I can't stress this enough that I'm not encouraging you to do either of those things, but there is some evidence to show that that might help your performance a little bit. All right, so why does this improve? State-dependent learning, context-dependent learning, why do these improve our memory performance? Well, our internal mental state and our external environment, these are all memory cues. When we are learning something, our mind is taking in every single piece of information that it possibly can, including our internal mental state and our external environment. So when it comes time to remember that information, our mind is going to be searching for those cues that were present during the study phase. If they're there, they're going to help us recall that information just a teeny tiny little bit. The basic idea here is make your study sessions as similar to your testing sessions as possible. Make your external environment as similar as possible. Make your internal mental state as similar as possible. All right, we're going to skip this about substances and memory, and we're going to jump right into models of memory organization. So we talked about a couple different models in the last lecture, and we're going to pause this lecture here and get started up with the second part shortly here.